Hi everybody, it's Mrs. Moran again, and I'm here to talk about the 3 ways we record multiplication. We've already learned all 3 of these ways, and we will spend this week reviewing them and spending more time specifically on the traditional regrouping algorithm. I'm going to show you these 3 strategies with the same problem so you can see their similarities and also their differences side by side. All right, so these 3 strategies are going to be our area model, partial products, which is an extension of the area model, and the regrouping algorithm. We're going to use 4,364 times 6 is our problem, and we're going to estimate first. And the importance of estimating first is to make sure that our answer ends up being reasonable and that it's in the right magnitude. So I'm going to round 4,364 down to 4,000. Multiply it times 6. That's going to give me 24,000, which means my answer should be somewhere in the mid 20,000s. And we'll make sure that I'm 100% correct, but I'll be able to catch a mistake if I'm way off. All right, so first example is the area model. And the area model, we spent a lot of time on last week. Basically, the premise is that we're going to take this large number and imagine it as an array, only rather than draw out 6 rows of 4,364 dots or circles, we're just going to imagine this as one large rectangular array broken up into smaller, simpler arrays, and then multiply them in parts and put them together. So we're going to take a look at 4,364 and then put that into expanded form. So that's 4,360 and 4. Okay, so we're going to be multiplying a 4-digit number in 4 simpler steps. So 6 times 4,000, even though it's a large number, is not a difficult multiplication problem. 6 times 4 is 24,000. 6 times 300 is 1,800, which is 1,800. 6 times 60 is 36 tens, which is 360. And 6 times 4 is 24. Okay, those are my partial products, and to get my final answer, I'm going to put all these together, making sure I line them up carefully. So 24,000. 1,800, 360, and 24. $26,184. My estimate was 24,000. I know that it was a little bit low on the estimate because I rounded that number down, so I'm content with saying that my answer 26,184 is reasonable. I'm going to come over here to partial products. Partial products is basically the exact same as the area model without having to draw out the boxes. It saves us some steps and really is still the same thing. We're still just breaking it up into place values using expanded form. So 6 times 4,000 is 24,000. 6 times 300 is 1,800, 1,800. 6 times 60 is 36 tens. 360, and 6 times 4 is 24. Okay, we'll add all those up just like we did previously. Okay, 26,184 again. Okay, so basically there is no difference in these strategies other than the area model uses an actual picture model. And sometimes that can help students organize their work when we get into working with 2-digit times 2-digit multiplication, which is coming up later this week. Okay, now on to the traditional regrouping algorithm. This is the one that we all learned, parents, as we were growing up. We were taught to do this because it is the quickest and the most efficient way. It requires the least amount of writing, but it's also the way that makes the least amount of number sense, and it's the one that is the hardest to catch mistakes. So when you get into larger numbers, multiplying times thousands and to the 10,000s and 100,000s, this definitely has an advantage over having all these zeros and adding up a long list of numbers. But I'll show you in a minute why this is so much harder to catch mistakes, and it takes just a lot of practice before you get good at it. But once they practice, it is much quicker, much simpler than using a partial products model. So we're going to start in the ones, just like we always do with addition and subtraction, because we know we're going to be regrouping. We always regroup smaller numbers into bigger numbers. So we'll start with our ones. 6 times 4 is 24. which we had over here. We already did 6 times 4. So same multiplication, I'm just going to be showing my work a little bit differently. So instead of writing 24 down here, I can't cram 24 into the ones place, so I'm going to put my 4 here, and I'm going to regroup this 2 up here. I don't know why, but for whatever reason, students want to switch those around sometimes and put the 4 up here and the 2 down here. So we're going to have to be really careful that they're understanding, if you slide this number down, it should say 24, not 42. And I don't know why that they do it backwards so often, but it does happen a lot. All right, next I'm going to multiply in my tens, just like we did over here. 6 times 6 is 36, but we're going to take that extra 2 tens from the part that we regrouped, and we're going to add on to that. So 6 times 6 is 36, plus 2 more is 38. Again, I can't cram 38 down here, so I'm going to bring my 8 down and regroup my 3. All right, now I'm going to multiply by my hundreds. 6 times 3 is 18, which we had that over here. There's 18 hundreds, but I'm going to add on that extra 3. That's 21. Can't cram 21 down here, so the 1 comes down. The 2 gets regrouped. All right, and then my last step is 6 times 4. Instead of having to write out 24,000, I'm just going to put my 24 into the thousands place, but I have that extra regrouped 2,000, so we're going to combine those. So 6 times 4 is 24, plus 2 more is 26. Okay, so the same thing, doing a lot less writing. In addition to just writing my answer, I really only had to write 3 other digits, whereas over here I had to write a bunch of number sentences. I have a lot more my basic facts with all these zeros in here, the true values, and the final answer. So yes, it's much quicker, but here is where it makes it more difficult. When I'm looking here at my multiplication, I want to go back and check, did I do my multiplication correctly? I can see right here my basic facts. 6 times 4, 24. 6 times 3, 18. 6 times 6, 36. 6 times 4, 24. Here, I don't have that. I never see the actual numbers I'm multiplying, other than when I did my ones. So 6 times 4 is 24 is not actually written anywhere here. It's here and here. The next number I multiply is 6 times 6, but that 36 is held in my head. It's not actually written down on paper because it's 36 plus 2 more is 38, where my 8 is down here and my 3 is up there. 6 times 3 is 18. That's what I'm multiplying, but 18 is not written down anywhere because I'm adding on those extra 3 to make it 21. Okay, so my 21. 6 times 4 is 24. Again, that's not actually written here. So it's very easy for me to go back and say, okay, there's my basic facts. I'm checking my multiplication. Yes. 3 zeros, 3 zeros, 2 zeros, 2 zeros, 1 0, 1 0. Did I line everything up? Did I add it correctly? Again, over here, the numbers I'm multiplying aren't actually shown on paper anywhere. So it's going to be really important if they want to recheck their work, that they have to go back through one column at a time, be able to multiply, hold that number in their head, and sometimes it's a very large number, and be able to add on another large number also in their head. So again, that's why this takes a lot of practice. We also have a lot of students who still are making mistakes on basic facts. And the numbers, 6, 7, 8, and 9s, we really need to practice those because students have these strategies. Every single student can do every single one of these strategies. They know what to do. They know these steps, but it's just takes a lot of practice in the beginning. They don't know their basic facts. They confuse where to regroup. Like I said, they might multiply correctly and add wrong, or they might multiply incorrectly and add right. So they, it's just really hard to find mistakes there. So we want to be really careful saying, oh, just do it this way. This is the easiest way, because it's really not. It is if you don't make mistakes, but if you're prone to making mistakes, they happen a lot more using this strategy. So in the end, here's what I want you to know about all of this. Really, you're doing the same thing no matter what strategy you use. All of them rely on the fact that you are breaking up the problem into simpler factors. You're multiplying a 4-digit number 4 times, thousands, hundreds, tens, and ones. Whether you start in the thousands with the partial products or whether you start with the ones and regroup, you're still just multiplying that number into simpler steps. So once you break up that number, then we're multiplying in steps. We're going to take those products, whether they're whole values like this or whether they're just digits put in a place value. Still just multiplying, and in the end we're just going to combine them, whether we're adding them or whether we're combining them in place values. All right, so we've done a lot of partial products already. The traditional regrouping algorithm is what we're going to want to practice this week. So keep working on that. And I know sometimes it's hard when they finally feel like they're moving in the right direction. Partial products was finally clicking, and then now I gave them a new way. So I don't do it to confuse them. I do it to show them because it is a traditional algorithm for a reason. As numbers get bigger, it is a much more efficient strategy. It just takes a lot of practice. So I appreciate your time, and thank you for helping out at home. Go ahead and like and subscribe to my video. Thank you.